So in the previous video we said that for all G in G, for all elements in the group, we have that there exists a G inverse. In fact, I'm going to call it G inverse of sub R, and you'll see why, in G, such that G star G inverse is equal to E R. Okay. So we have this. What we want to show is that G also happens to have a right inverse. That means there exists that given a G, we have there exists a G left. Sorry, I should say left inverse, such that G star G is equal to E R. So how can we prove this? Well, we'll start off by saying G star GR inverse equals E of R. And then what we'll do now is multiply by GR inverse star G star GR inverse star G. So we multiply this on the two different sides, so here and here, and we'll do the same on the right hand side. So we get GR inverse star ER star G. And since E is a right identity, we have that this is equal to G inverse R star G. This side over here, we get two lots of those. So what we can do is, because we know that there is a right inverse for every element in G, because we said so, we can actually cancel these out, cancel this and this out, by multiplying by the inverse on this side. Okay, and then what we'll get is that G inverse R star G is equal to E R. So basically what we said here. Sorry, we used the rule we said here, but what we got is now that what we got instead is that we just found out what the left inverse is, and it actually turns out the left inverse is actually equal to the right inverse. Okay, and so we know that so what we just shown that is that if that we knew from the axioms that G had a right inverse, and now we've shown that that right inverse is also the left inverse. So now we don't actually need to use these subscripts L and R. We'll just assume that we use the same inverse in either case. So in this case, I'll write it down just so we know it. I haven't written down something actually obvious. Okay, so now we want to show that there is actually, so the next thing we want to show is that there is a left identity. And unsurprisingly, actually turns out that the left identity is equal to the right identity. Okay, so how do we show that? Well, we start off with what we know. We know that there exists a right identity. So we don't know this yet. This is a prop. And we start off with this. And then we have that, we have from here that there is that G inverse, that this is actually just G inverse star G. But then we also know that this is ER, and therefore we have that this is equal to EL. So I hope you followed up. What we did first is that we showed that we just substituted ER with what we proved ER to be, which is G inverse, the right inverse times G, but we know the right inverse and the left inverse are equal, which is what we proved before, so we can just put this in, and then we can multiply, use the associativity property to multiply in a different way, and then we can just show that ER is also a left identity, and we have what we wanted, which is the left identity. And now we can just say E instead of right identity and left identity. Okay, so in the next video, now we've shown that there's a right inverse and left inverse, and which are the same, and there's an identity, the right and left identity, which are the same. We'll just call them the identity from now on, and the inverse from now on. And we want to show that they're unique. There's only one identity element, and for every G, there's only a unique inverse. So that'll be the next video.